So far in this series, we've covered single agent patterns like React and Codact in part 1 and multi-agent systems like Orchestrator Worker and Swarms in part 2, links to both in the description. But here's a problem we haven't addressed. Freeform agent loops are powerful, but they're unpredictable. An agent might take 3 steps to complete a task one time and 30 steps the next. It might call tools in a different order every run. For enterprise production systems, especially in regulated industries, that unpredictability is a deal breaker. You need structure, you need control, you need workflow-based architectures. Think of agentic architectures on a spectrum. On the left, fully autonomous freeform agents. They decide everything at runtime. On the right, fully deterministic pipelines. Every step is predefined. No LLM reasoning about what to do next. Workflow-based architectures sit in the sweet spot between these extremes. They give you the intelligence of LLMs at specific nodes, while the overall flow is defined and predictable. You get the best of both worlds. AI reasoning where you need it, deterministic control where you don't. The most common workflow pattern is the DAG pipeline, a directed acyclic graph where each node represents a step in your workflow. A node might be an LLM call, a deterministic function, a conditional branch, or even a nested agent. The key property of a DAG is that there are no cycles. The workflow always moves forward. See those 3 nodes running in parallel? That's a huge advantage of DAGs. When steps don't depend on each other, they execute simultaneously. This dramatically reduces total latency compared to sequential processing. In this example, cost modeling, migration planning, and risk assessment all run at the same time. Each node can have different characteristics. Some are pure LLM calls. Analyze these table schemas and identify dependencies. Some are deterministic functions. Calculate the EMR pricing based on this cluster configuration. Some are conditional branches. If the schema has more than 100 tables, route to the large-scale assessment path. The frameworks that enable this pattern include LangGraph for Python native DAGs, AWS Step Functions with Bedrock for AWS native production workflows, Temporal for durable execution, and Prefect for data pipeline orchestration. For enterprise AWS stacks, Step Functions plus Bedrock is the most production-ready option. You get built-in retries, error handling, and CloudWatch integration out of the box. The state machine pattern takes control one step further. The agent can only be in one well-defined state at a time, and transitions between states are triggered by explicit conditions. You define every possible state and every valid transition up front. Nothing happens that you haven't anticipated. Let's trace through an example. The agent starts in the analyze state, where it examines a set of Hive queries. If analysis succeeds, it transitions to generate, where it produces PySpark equivalents. If generation fails, maybe it encounters an unsupported Hive UDF, it transitions back to analyze for deeper investigation. If generation succeeds, it moves to validate, where it runs comparison tests. If validation fails, it enters revise, fixes the issues, and loops back to validate. The massive advantage here is auditability. At any point, you can answer what state was the agent in? How did it get there? What triggered each transition? For regulated industries, healthcare, financial services, and government, this level of traceability isn't a nice to have. It's a requirement. State machines also prevent runaway behavior because the agent literally cannot enter a state you haven't defined. The trade-off? State machines require more upfront design. You need to think through every possible state and transition before you start building. They're less flexible than DAGs. Adding a new path means redesigning the machine. Use them when predictability and compliance matter more than flexibility. Plan and execute bridges the gap between freeform reasoning and structured workflows. The agent first creates a complete plan, then executes each step sequentially. If a step fails or reveals new information, the agent revises the plan and continues. There are 3 distinct phases. Phase 1 is planning. The agent receives the full task and produces a structured plan, typically as a numbered list or JSON object. This is where a powerful model shines. It sees the whole picture and designs an efficient approach. Phase 2 is execution. Each plan step is executed one by one, with results captured. A cheaper, faster model can handle individual steps. Phase 3 is replanning. If any step produces unexpected results, the agent returns to the planning phase with new context and revises the remaining steps. This is fundamentally different from React. In React, the agent figures out the next step one at a time. It's myopic. In Plan and Execute, the agent sees the full journey before taking the first step. This gives you global coherence. Every step is designed with the end goal in mind. That's why Plan and Execute works much better for long, multi-step tasks like end-to-end code migrations or comprehensive assessment reports. The nuance is in how replanning is triggered. Some implementations replan after every step, expensive but adaptive. Others only replan on failure or surprise, cheaper but might miss optimization opportunities. The best approach? Replan when the actual output significantly deviates from what the plan expected. Let's put the three workflow patterns side by side. DAG is your default for most production workflows. It's well supported by frameworks, enables parallelism, and is reasonably flexible. State machine is your choice when compliance and auditability are non-negotiable. And Plan and Execute is ideal when the task is complex enough to need upfront planning, but unpredictable enough to need adaptation. That's part 3. You now have 3 workflow-based patterns for bringing structure to your agentic systems. DAGs for parallel pipelines, state machines for auditable control, and Plan and Execute for adaptive planning. But what if your agent could evaluate its own work and get better? What if it could ask humans for help at exactly the right moment? And what if your RAG pipeline could reason about what to retrieve? In part 4, we cover reflection patterns, human-in-the-loop design, and agentic RAG, the techniques that make agents truly intelligent.